Example 6, substitution in a definite integral. We're going to evaluate the integral of the square root of 2x plus 1 dx using number 5 going from 0 to 4. Okay, so here we're going to write out the integral. So we know that we have an integral that's going from 0 to 4, the square root of 2x plus 1 dx. Okay, so first thing we're going to do is we're going to let u equal 2x plus 1. And we know that du is going to equal 2 dx. And in our problem, we want to solve for dx, so we're going to divide both sides by 2. So we know that 1/2 du is going to equal dx. So there is our substitutions. Okay. Now, because this is a definite integral, then this means that our limits, our upper and lower limits, are going to change when we put in the value of u. So let's do our substitution. We know the square root of 2x plus 1 now becomes the square root of u. And we know that dx is going to become 1/2 du. Okay, so now we also need to take into consideration what's happening with our upper and lower limits. So if we look at our lower limit that's given, we know that x is equal to 0. And so we got to substitute that in for u, because now u from this is going to equal 2 times whatever x is, which is 0, and then plus 1. So this becomes 0 plus 1, which is 1. So now our lower limit becomes 1, and we have to do this every time we find a definite integral with upper and lower limits for this substitution. And then we also know that the upper limit is going to equal 4, so x is going to equal 4. So we have u, which is now going to equal 2 times 4 plus 1. Well, that's 2 times 4, 8 plus 1, which is 9. So now the upper limit is going to become 9. Now we can go ahead and then evaluate this integral. So we can factor out the 1/2. So we have 1/2 with a lower limit of 1 and upper limit of 9. And this is now u to the 1/2 du. So now let's find the antiderivative of this. So we have 1/2 times the antiderivative, which is 2/3 u to the 3/2, and that has a lower limit of 1 and an upper limit of 9. And so now let's factor out the 2/3. So we're going to have 1/2 times 2/3, and then we're going to evaluate u to the 3/2 with an upper limit and lower limit of 1 and an upper limit of 9. Okay, so let's go ahead and do that. So we have 1/2 times 2/3, which is going to give us 1/3. And then we're now going to evaluate this integral. So that means we're going to have this 9, which is the upper limit to the 3/2, minus 1 to the 3/2. And so we end up with 1/3 times 27 minus 1, which gives us 26/3. Okay, so again, whenever you're using the definite integral, and once you do your u substitution, we need to convert these upper and lower limits using the u substitution. Very important. It's a common mistake here. Okay, now, let's take a look at the graph here. Okay, here is y is equal to the square root of 2x plus 1, y is equal to the square root of u over 2. Okay, the geometric interpretation of this example is shown in this figure. The substitution u is equal to 2x plus 1 stretches the interval from 0 to 4 to what? 1 to 9. Okay, so it's by a factor of 2, and then translate it to the right by 1 unit. So the substitution rule shows that the two areas are equal. So this area here is actually equal to this area.